All right, so we're going to introduce a couple of other properties now. So internal energy and enthalpy. Internal energy is we use a letter U for that. When we use an uppercase U, it's in kilojoules or BTU. So it is a unit of energy, and it encapsulates several types of energy. So the first type is sensible energy. This is associated with disordered or disorganized microscopic kinetic energy. So that's opposed to macroscopic kinetic energy, such as say a car is going down the road, say the car is the system, right? That would be macroscopic kinetic energy. Microscopic kinetic energy is, well, we've got an example over here. So you could see this is a diffusion experiment. You could see the molecules are moving around a lot more quickly with hot water, right? They have a lot more, in the hot liquid, those molecules have a higher microscopic kinetic energy than the cold water. And so, of course, you see that red dye is diffusing a lot more quickly than that blue dye. Internal energy is also made up of latent energy. So this is associated with phase change. It takes a certain amount of energy to go from a solid to a liquid to a gas. Chemical energy as well. So this is associated with the bonds between atoms. And then the last one would be nuclear energy, which is associated with nuclear bonds. Um, so when we talk about internal energy, uh, oftentimes we're not really concerned with the value itself. I mean, obviously we're going to be concerned with the value itself, but what we're primarily interested in is the change in internal energy. And anytime there's a change in entropy or in anything defined, so internal energy or enthalpy, like we'll talk about in a second, it is what it is after minus what it is before. So U2 minus U1. Now, this is an extensive property. So if it's a capital letter U, it's an extensive property. It is dependent on the size or the mass of the system. If we wanted to make it an intensive property, we would use lowercase u. So lowercase u is kilojoules per kilogram. It's capital letter U divided by the mass. And this is because it's an intensive property, and it's going to be something that we can actually look up in our thermodynamic tables. If it's saturated, we'll just go to our saturated tables and we'll use equality to calculate what that internal energy is. Those subscripts, the subscript F and G, are referencing the saturated liquid portion of that two-phase mixture, and U sub G is referencing the saturated vapor. U sub FG is just U sub G minus U sub S. Sometimes there's a column that has U sub FG already tabulated for you. So enthalpy. So this is a combination property. It's U plus pressure times volume. Now this is something that comes up quite a bit, this combination of properties, and so we just give it its own special name. On the left-hand side, the uppercase H, that's going to be an extensive property. The one on the right-hand side is uppercase H divided by mass, and that's an intensive property, and that's something that we can look up. Again, oftentimes we're concerned with the changes in these properties, so just keep in mind anytime you see a delta, it's what it is after minus what it is before. So state 2 minus state 1. And if it's saturated, we'll use the quality just like we do for calculating values for saturated, whatever the substance is for internal energy and specific volume. So all of them use the same sort of generic formula. All right, well, I hope that was helpful. Thank you for watching, and let me know if you have questions.